Okay, in the last session we were discussing about horizontal pod autoscaler. So horizontal pod autoscaler we can do in two ways. One is for CPU and one is for memory. Whenever there is a huge CPU, we can create automatically the pods, and whenever there is a huge memory, then the pods gets created. So in the last session we discussed and practiced about how pods get created automatically whenever there is a huge CPU for a pod. So today we'll see about memory, and then we'll see about ELK, okay, EFK, Elasticsearch, Fluentd, and Kibana. So let me power on this machine. So for that, I will log into this Jenkins server. So here I log in as a Jenkins user account, and if you remember, I went to the Helm chart. I did not configure any job for this one. From here directly, if you see Helm list, I okay, I think master yet not yet ready, I think so. Okay, it's telling teller is not ready. So if you see here, inside this, I went to workspace directory, and here the job pet clinic cd job, and inside this we have an Helm chart. If you see inside this pet clinic Helm chart, under the templates directory, I configured this one. So now I'll remove this file, and I'll create a new file, and inside that I'll put the belongings of memory related stuff. Okay, so let me go to my repository. This is the one memory HPA, and this is the file I need to copy inside the Helm chart. So I'll remove this file, and I'll create a new file, petclinic-mem.yaml file, and inside this we copy this stuff. So here max replicas 5, minimum replicas 1, same, and this horizontal pod autoscaler we are configuring for this specific deployment. So this is the deployment name to whichever deployment you are providing this one, and this is an type, resource type is memory, and here whenever the memory utilization is 50%, then it will trigger a new pod. Okay, this is up to us. We can give 60, 70, 80, 90 in our organization, whatever the uh, average utilization the application users will ask. Based on that we can configure it. Now I'm going to save this one. Okay, so now let me log into the cluster and see. In the meantime, let me see it is up. Yes. Now if I check Helm list, if you see, this is the deployment I've done on the Friday, I think so. Friday or Thursday. Okay. Now Now if you see, this is a pod. Why it is running 3? Okay, so this is a deployment. Okay, on that day it got created. So I think so afterwards it did not get deleted. kubectl. So now I'm going to delete this deployment and I'll deploy with the new configuration because I have changed with the memory HPA. So again we need to deploy it. So for that I am going to delete this deployment. So Helm list in the Jenkins server, Helm delete. Now there is no deployment, and here also we can see this will get deleted. Once it is done, again I'll redeploy it so that now it will deploy with the memory HPA. Okay, done. It got deleted. Go to my Jenkins server and the previous command which I used, Helm. Okay, this is the command which I used. Helm upgrade -f install, and this is a release name, and this is a Helm chart name, and I should be inside the directory. So let me come out of the directory. Yes, right now I'm inside this directory, and this is the image from where the image should be pulled. Okay, so now let me execute. It deployed. Now if I come to the cluster and see, it's created. And if you see kubectl get HPA, here we can see pet clinic -memory HPA. If you have enough resources, then I could have deployed both CPU. I could have placed the CPU also in the same Helm chart. Both in real time will mention both the YAML files in the Helm chart. But as of now, our workers doesn't have sufficient resources. So what happens whenever we have only one CPU left in each machine? So whenever the pod creates, so by default it will rise up to almost one CPU. But as per threshold, immediately it will create a new pod, right? So that's the reason I did not include CPU inside this. If we have enough resources, enough CPUs and RAM, then we no need to delete the CPU related file. So we can have the CPU related file and we can have this memory also, both the files in the Helm charts. We need to put both the files in the Helm charts in real time. But as of now, due to insufficient resources, I deleted that and again I'm using with this memory. Okay, and now if you see by default 21% it is using kubectl, 219 MB of RAM it is using by default. Okay, so now what we need to do, we need to test it. So how to test it? Again we need to use some commands. So install stress package inside the application pod. So last time we installed siege package in one of the Linux machine. From there we sent some HTTP traffic to our URL. Now this time inside the application pod we need to install stress, and we need to execute this command. Okay, so stress command will eat up the memory so that it will use maximum memory, then it will um, trigger a new pod. So let me log into the pod. So I hope you know how to log into the pod. kubectl get pods, take the pod name kubectl, and by default this will be Debian machines, right, or Ubuntu. Based upon that you need to use the command to install the package. It's a Debian Linux. Okay, why? Because we were using OpenJDK as a base image inside the Docker file. So OpenJDK, how it got created, they used, when we are using OpenJDK from the Docker hub, so they created that OpenJDK from Debian. So that's why we can see Debian. So now first use apt-get. If you are using some other application, okay, and if you are using some other base image, then you should use whatever the image you are using. Then based on that you need to use, if it is CentOS, then use yum install, or if it is some, for example, alpine is there, that is different command it will use alpine. Okay, not Debian, not apt-get or yum install. Alpine will use some other command to install packages. Okay, so that way based upon the OS you need to use it. Apt-get update and apt-get install stress. Okay, stress command is installed, one newly package is installed, and then install this command. And before that, let me open another session of this one so that we can monitor the CPU memory usage. Okay, now if you see 417 MB, now 662 MB, and now you can see 64% the memory utilization. It is 50% actually, the we configure the threshold, and it is now 64%. And now you can see replicas 2 because of this one. Now we can see in the get pods. So now second one has been created. Okay, so if you see the still resources, now it is reduced because the command, I think it's been terminated, it is reduced. So here 500 MB of RAM we are utilizing, okay, in one single go. So we have we provided 1 GB of RAM, right? So that is why we provided 500 MB so that it can use up to 50%. So based upon how much resources we are allocating, based on that we can provide if we are using some other different application. And overall memory itself we are providing that application maybe 500 MB or 250 MB, something like that, then you can change this value according to that. Okay, I provided 1 GB of RAM for this application, that's why here I'm providing 500 MB, so it will eat up 500 MB of RAM. Okay, now it is reduced, but as I said, based upon the cooling period 5 minutes, it will delete the pod. It will take time, immediately it will not delete like how it got created immediately. the same way it will not get created deleted. It will take cooling period time 5 minutes, then only it will get deleted. So we can see get HPA, right? If you see describe HPA, and this is a name, you can see these transactions whatever is happened now. Okay, this one new size, reason memory resource utilization percentage of request. Okay, about target, so that's why it created new pod. Okay, as I said, you can ignore this one because whenever it's initialization time it will get an error, because at the time HPA will not get ready to get the details of, because whenever the metric server is collecting the information, it will take time to connect with this HPA. During that time, you'll get this error. We can ignore this. After that, again after it, the pod get deleted, it will update here. Okay, the new size 1. Okay, and again it will tell the reason why it is one size, because it is a utilization is normal. The memory utilization will be normal. So in the describe command, you can check this one. Okay. So now current 2, max 5, but basically we configure one replica. So this is how we configure uh, horizontal pod autoscaler. Even there is an option for vertical also. Vertical means what? Providing resources to the existing pod itself. But mostly that will be not used. 95% we use this option only, auto scaling. When we use vertical scaling, if your application is not supported multiple replicas, means see, uh, I there will be a application, some application will be the sticky sessions will be there. Okay, means um, whenever a user, let's say I'm buying something inside the Flipkart, I selected something and it is into the cart, and again I went back to the main web page and again I'm trying to buy some other thing. So back end Flipkart might have multiple servers. So whenever I selected one item, first it went to one server and it provided that information, it's stored there. Again, if I'm going to buy second item and that request goes to second server, how come second server knows that I already have an item in my list? Okay, so there will be a concept called sticky sessions. Okay, so based on that concept only, the sessions will be configured. Okay, all these items will be, even though was placed in a centralized way. That is a huge concept. So if that is not supported by your application, so what you need to do, if it is generating a new session for every connection, then it will be a problem. So those kind of scenarios, you cannot have multiple pods, right? Only single pod only should be available. Then that pod resources should be increased whenever there is a huge load. If load is high on that particular pod, then it should be increased with the resources. In that scenario, you can configure vertical scaling, but that will be very, very rare scenario. Mostly we'll get opportunity to configure high availability, okay, fault tolerance for our application. So we can use horizontal pod autoscaler itself. Okay, so now we'll see EFK, Elasticsearch, Fluentd, and Kibana. So when we initially first time, for example, in our organization, we started using Kubernetes for our applications. The first step is build the cluster. Whether you are building it in cloud, if if your customer or if your project is in cloud, then they'll recommend any of the cloud. Or initially for testing purpose, you might start with on bare metal, like creating virtual machines, installing with KubeADM. That up to your project. So once you deploy your application, you will first initially create files, Jenkins files, Helm charts, all these things. You'll configure jobs, you'll deploy. Once you see everything is getting deployed, then next requirement will be logs. So you want to see the logs. How you are going to see the logs? So application logs you want to see, because once you deployed, you cannot give access to your cluster to execute these kubectl commands to the application users. They don't know about this, how they will use these commands, right? They don't want to go to cd var log something like that, because if it is a virtual machine, there will be some path will be there, they'll go to that location. For example, if this is a virtual machine means application team will configure the logs to some location. So there we can create a user account and we'll provide access to access the log file, or they will have their own application file system itself. See, whenever application team is working on their application, apart from OS related file systems, we'll create separate file system in the Linux operating system for application guys. For that file system, we'll give full access to them, because the user group will be there. For example, if it is an Apache username and group name will be there to that file system, so that they can do anything to that file system, right? So they can go to their log file also and see, that is okay. But here it is a pods concept, right? To log into the pod, you should have Kubernetes knowledge, and we should not give access to that cluster also. So instead of that, we can provide some centralized location where they can see the logs easily, right? So to see that, first of all, your application logs should be configured in a such a way. For there are two types of logs they can configure. Means one is, if they configure the log as a standard output. Standard output means what? Whatever the logs it is generating, it is not redirecting to any file. It is just giving the output. Like whenever we execute any commands, we'll just give the standard output to redirect to a file, right? Or else it will display on the screen itself, on the console itself. So same way, standard output means what? It will display immediately whenever the application executes. It will display the logs also there itself. Okay. Or else application will configure to redirect to some file, so that we'll go to that file and we'll open the logs. That way it will happen. Okay. So now, if in case your application is configured with standard output as a log option, then if you see, for example, kubectl get pods. Now kubectl kubectl logs and the pod name. If you mention this way, you can see here with this command. If your application is not configured with standard output, then you cannot see any logs with the kubectl logs command, because it is available in the log file. Kubectl logs command will not go and read the log file. It is only giving the information from the console output. Okay. Now if you see started application, now for example, okay, I access this, right? So now again I'll try it. Last line was started petlink application. This is the last line. Now if you see completed initialization in 19 milliseconds, someone accessed this. Okay, so that's why this is showing the information. So it is giving the logs to an standard output. So that's why when I type kubectl logs command, we can able to see. Okay, but sometimes the application will be, mostly the application in real time will not be configured as a standard output. They will be redirected to a log file. Okay, but I will show you if EFK is configured. So what it will do, it will collect this all the logs information and it will send it to the Elasticsearch. I will show you with the diagram. Okay, how it will be. this image will be perfect. Okay, so we have a concept called Elasticsearch, Fluentd, and Kibana. So what is Elasticsearch? Elasticsearch is like a database which will collect all the information, which will store the information. This is called storage. And inside the storage, it will store all the information. So who is sending that information? Fluentd is sending the information. So this is one worker node and this is one worker node. Here example, some Wildfly application is running and here Java application is running. Okay, some applications are running inside this one. So now whatever the application log files will be there, that will be captured by this Fluentd, and this Fluentd's responsibility to send that information to Elasticsearch. So this Fluentd will be available in each and every worker node, so that it can, whatever the, if 10 pods are there, 20 pods are there, whatever the pods are there, it will collect the information, and that information it will store inside this Elasticsearch. So Elasticsearch is going to have the volumes, because it is storing the data. You need log files of 1 week or 10 days. It's up to your application owners how long they want the log files. Even in our organization also, if you take our virtual machines concept, log rotate concept will be there. Based upon the application team request, we will configure log rotate so that for how long we need logs, so that after 1 week logs can be deleted. Okay, so same way here also, for how long we want, so we need a volume compulsory, because if this pod gets deleted, then if there is no data, we need yesterday's logs or day before yesterday's logs. So that's why here it is contains a volume. We already discussed about volumes, and it will store the data inside these volumes. Okay, and Kibana is the visualization. Okay, it will collect the, fetch the data from this Elasticsearch, and it will give you a visualization data analysis. Okay, how you can uh, see the logs in a visual way, that will provide you the dashboard. We can call it as a dashboard, the Kibana dashboard. We will provide that URL to the application users, so they will check their logs inside that Kibana dashboard. Okay, so now we will see how we can deploy. So these three components we can deploy it with an Helm chart. We can have, or else you have YAML files for each individual um, resources, then you can configure it. So this will get deployed inside the Kubernetes cluster. Okay, so Elasticsearch, Kibana, and Fluentd as a pods will get deployed. So now, as I said, if it is an standard output, for example you have 3 pods inside this worker node, and these 3 pods applications are configured with standard output, then you don't need to configure anything extra. Automatically Fluentd will capture that information and it will send it. But if there is a no standard output configured for your application, if it is redirected to some what we say log file, then Fluentd, how come Fluentd knows that there is a log file location and should go there and should pick up? So in that scenario, we have a concept called a sidecar. We call it as a sidecar container. Okay, so here, I don't know where I mentioned that sidecar details. Okay, so here I separate configured mentioned this paclinic.yaml file under the Kubernetes repository to show you the same deployment. Previously, how we deployed our application, the same deployment, but in case, for example, if the pet clinic application is not configured with standard output, the log file, if they configure inside some any path, let's say var log, then if you see in the specifications, containers, so this is my application container. We are telling this is the name of the container and this is the image location and this is the tag it need to use. Image pull policy means we can use if not present or always also. Means if already present, it will not pull from the Docker hub. If always means always it try to pull from the Docker hub. Okay. And what is the inside application port is configured in the application level that we are configuring here. Okay, till here. And again, if you see in the same column, name is there, count log one means another container. This image is busy box and arguments. If you see in the arguments, this is the tail command -n plus 1 -f. This is the log file location. Okay. So, and this what we are doing. So inside this container, we are mounting our pods var log to this particular container, and then it is doing tailf. Tailf means what? Whenever we are doing tailf, it's like a console output only, right? So for example, cd var log tailf hyphen messages, what will happen? It will give me the continuous output here if the logs are generating. So it will give me the output. If you see, this is the message right now. So maybe see now this is a message. One more thing I got like this. Whatever the output we are getting, so the tailf command what it is doing, it is giving the live messages, okay, continuously. So here also what we are doing, the pod, wherever the pod application log is there, okay, this content application log is there, that location we are mounting into this container and we are doing tailf command to that log file. So when you are doing tailf, so automatically it is like a console output, standard output only. Then what will do, the fluentd will collect that information and it will send it to the uh, where Elasticsearch. Okay. So when I was configuring, because I got opportunity to in my organization, in my project to confirm from scratch, I started creating everything from bare metal to AKS cluster, GK, everything. So when I got this stage to configure, initially I was struggling how I need to configure, because directly if I install EFK, it will just only search the standard output logs and it will give in the dashboard. So it took time for me by doing a lot of research. Then I got to know, okay, this way I can get the logs of the pod. Okay, because wherever this container got created, so what, which as I said, for application container, if they configure log file is a var log, some location is there, that location we need to mount it here. Okay, in the second pod, mount path. Otherwise, if you just give tail -f command, it will say the file is not found inside the second pod. How it knows that there is this is the file? So we are mounting this path of this container. So that's why inside this container, when you do tail -f, then it's like an NFS share or something like that. So you can able to get this file, and then you are doing the tailf command so that it can able to get the information. So it's giving console output. That's how our fluent is collecting the picking up the information and sending the to the Elasticsearch. This is the cluster, and these are the nodes. See, Elasticsearch, if this is an Elasticsearch and this is uh, fluentd will be available by default in all the worker nodes, because it need to collect information from all the worker nodes, right? So how many worker nodes are there? In all the worker nodes, fluentd will be there compulsory. And Elasticsearch again, it depends upon how many replicas you configured. If I configure 2 replicas, assume this will be on deployed on the 2 machines, so it will be So mostly we need to provide 2 or 3 compulsory, because there will be no high availability, right? If you don't provide more than 2, more than 1. So minimum if you are providing 2, then it will be deployed in 2 work nodes. And assume if you have only one Kibana dashboard, and that will be this one. Means if you configured only one replica for this way. It's not mandatory it will be available here. It can be available here or here. Okay. So, and inside this application pods will be there. Now assume these are the application pods. Okay. So in this pod, 2 containers will be there. So we have one container and another one is the side. We call this as a sidecar. Okay. So you can just go and do that also, sidecar container.
Praveen,
Sidecar. Yep.
with single container can't we achieve this?
Sorry.
Only with app container.
Hmm.
Can we achieve logging mechanism as well? I mean,
No,
having one pod
with
per.
sidecar only,
Okay.
it will be possible. Or
Okay.
else there is another option. See, there is multiple options will be there. There will be another option will be there. Okay. If you have only single, what we say, single file location, means if your application in the pod only have one file for log, then no need of sidecar container. There is another option, the standard output you can redirect. You know, right? In the Linux we have a link file. Okay, we
Yes.
can do soft link, hard link. So that file you can redirect to the standard output. Okay, in /dev there is an option. Okay, this way. So for standard output, if we link the file, then what will happen? That logs will be redirected to this standard output, and it will give display over here. You don't need to configure um, sidecar. In that application pod itself, you can create a link file so that it will be redirected. That will be, you can configure inside the configuration here. Here itself, same way how we are using command here, arguments. In this container, we can provide a argument command here, and we can do link to ln-s and the log file location, and to the /dev/standard output std out. Then logs will be redirected. If you have more than one log file, then that is not possible. So then we need to use this concept. But recommended is, this is a best recommendation, even though if you have single log file also, the standard output, because if huge logs are getting generated, then your it's very uh, quickly the logs are getting generated. Then better to use this concept instead of linking that log file to standard output. Okay.
Praveen. Yes. Got it.
So here we need to deploy this. As I said, this is we need to give replicas, and here if you see, we are using the deployment type here is stateful set for this one, Elasticsearch, and for this one is daemon set, and this one is deployment. I hope you all remember this deployment types we discussed: stateful set, daemon set, replica set, deployment. Okay. So for applications, we use this type deployment because we have multiple options, right? And daemon set, what is a daemon set? What is the purpose of daemon set we used for deploying applications or anything?
Uh, Pod in every node.
Exactly. So pod will get deployed on every node. Okay. So that is the purpose of daemon set. Here we don't give any replicas. Okay. So its responsibility is to go and deploy. And even though if the new worker node is gets created, maybe due to heavy load, right now we discussed the horizontal pod autoscaler. So when it gets autoscaled, if pods having sufficient resources on any of the worker node, then only it will get created. But if the pod doesn't find any resources in the worker nodes, then pod will be in the pending state. It will not get created because it will tell insufficient resources. Then how these virtual machines also should get created automatically. So in the AKS or GKE or EKS, we have an option called auto scaling option. We need to configure it. In Azure, we call it as a virtual machine scale set. In AWS, we call it as an auto scaling. In GKE also, we call it as an auto scaling. So we need to configure at the time of creating cluster, we will get that option to auto scale. So that features also, that values also we need to provide maximum how many up to what number it can grow. So whenever there is insufficient resources, then these virtual machines also will get created automatically. And whatever the pod was showing in a pending state, that will go and deploy on this machine. So this everything should be automated. Okay, if you are using a cloud native Kubernetes cluster. So when this machine is created, then this fluently also should be get created automatically over here. We should not manually do that, right? Because we are not aware when automatically got this got created and when application pods got deployed. So daemon set will do automatically fluently will go and deploy into the new worker node. So it will check, the fluently will check this is a new worker node has been added into the cluster, and it will validate whether fluent is available or not. If it is not available, it will go and deploy automatically. So that's the purpose of daemon set. So it's responsibility to available in each and every worker node. And when this got deleted, this machine got deleted, then this fluently will be always obviously it got deleted. Okay, so that's why we use daemon set. And stateful set, as I said, here Elasticsearch is going to have a concept something like master slave concept, because by default as per Elasticsearch configuration file, they'll provide 3 replicas. Okay, 3 will be created. So 3 means one will be like master, remaining will be like slaves. Means fluentd is going to will not send to all, it will send it to one master. Okay, so one will act like a master, remaining will act like a slave. So to understand this concept between them, those 3 pods, so stateful set will do the justification, because stateful set, as I said, it will not deploy all the pods at a time. It will deploy one by one. First one will be created. After created of first one, everything is up, then only second one will get created. After second one is completely up, then third one will get created. Okay, in the concept of daemon set or deployment, or maybe in the replica set, the pods, if you mention 3, all the 3 will go and deploy at a time parallelly, but in stateful set one by one. So for master slave configuration, it required that concept one by one, not all together at a time. That is the one reason. And if you are using volumes for your application, the recommendation is Elasticsearch. Okay, so here for Elasticsearch, we use volumes. So that's why it is configured, it should be deployed with the stateful set. Okay, so if you see, even in the default Helm chart, in the native Helm charts, if you see Kubernetes Helm charts, so you can just go EFK Helm chart. Hmm, where is the default one? Some other persons also will place by doing some modification. See, again by default here, this EFK Helm chart, inside this default stable Helm chart location will be available with the MDDR volume, but in real time we don't use that one. So wherever you are using, You should use, if it is in a cluster, means AKS cluster, you should create some Azure storage, and that Azure storage you need to create as a persistent volume, and then you can create a persistent volume claim, and then you can give it to the Elasticsearch so that the data will be available. If you are using MTTR, means what? If the pod gets deleted, the data will also get deleted. For testing stage initially, you can use MTTR. You see here, this is not default Helm chart. This is some person is having his own Helm chart by doing some modification inside that. If you go to the Elasticsearch, and these are templates, and this is values.yaml, this is Helm chart, and here we don't see much files. Hmm. EFK Helm chart stable repo. Stable. This is the default location of Kubernetes Helm charts. So here we can search. Okay, here we can see these many Helm YAML files, but we don't need these many YAML files to configure. Okay, so but still we can see this is a stateful set. This is a master stateful set, and lot of other files are also available. We don't need this one. So what I have done, I have my own location here. Where is my location? This is my repository, and here if you see EFK repo, if you go inside this, these are the Helm charts. Okay, so now here if you see, this is a stateful set, and this is a Fluentd daemon set, and this is Kibana deployment. These are three deployments, and for this, for Elasticsearch, one service is there, and for Fluentd there is no service, and for Kibana there is service. Why? Because Elasticsearch, why it is having service? Because Fluentd will go and talk to the Elasticsearch. Fluentd collecting the information from the worker nodes, and it should send the data to Elasticsearch. So how it will communicate to the Elasticsearch? It should configure with some service. So internally itself, right? So internally it's communicating. So we no need to configure load balancer or node port. We can configure with the cluster IP, so that it can communicate whatever the name has been provided in the cluster IP. That name can be configured in the Fluentd configuration, so that it will send the logs to the Elasticsearch. And why we have service to the Kibana? Because Kibana dashboard you are accessing from the external world. So obviously if you see ESF service is configured with cluster IP. Here it did not mention any node port or load balancer. Means by default it's a cluster IP. And if you see Kibana service, it's a load balancer. Okay, because this should be accessed from the external world. Because application guys will access in the browser this Kibana dashboard. So whatever the IP it will provide, it will access from the external world. And this is the service. If you see stateful set, and this is and by default it is expecting the stateful set. This Elasticsearch is expecting, like how Tiller was expecting some roles in the cluster. So this is a service account, this is a cluster role binding. So actually in the same file it is available all this configuration, and by default whatever they are providing, where is it? Here they have individual files for this one. If you see role binding, role, and cluster, for that individual files are available, but we can have all together in a single file also. So service account, this is one kind, and cluster role, and this is cluster role binding. These are the three. so that Elasticsearch is having authority to contact the cluster and getting the information, the log files. So it's like providing permissions. And these are the four uh, objects are getting created. And then from here, exact deployment is happening. If you see Elasticsearch deployment itself, and kind is stateful set. Okay. And from where that image is pulling, this is the image location in real time. When you are applying this in your organization, you should be careful, like from where you are picking up the image, and always remember all these three should be in sync. Make sure that these three images are in compatible with or not. If you choosing the different images for these three, then Kibana dashboard, when you're trying to access Kibana dashboard, it will not give the proper information. So when you are trouble, because even I've faced a lot, okay, by accessing the logs by in whenever I was configuring this one. So because I was using that some different images. So given a dashboard can able to access, but it is not able to provide me the logs information properly. I'm getting errors. So then I realized, and by getting the errors, then I Googled it and I raised some queries with the forums, and then I came to know that the first of all images should be compatible. What are the images you are using? So that you can find in the Elasticsearch website. Okay, so if you go default Elasticsearch website, they will give the compatibility with this Elasticsearch, which image of Fluentd is compatible, which image of Kibana is compatible. Based on that you can configure. And how much resources, again it's up to your organization, how much of logs it is going to generate. Based upon that you can configure the load. Okay, and here if you see mttr volume is getting created. For testing purpose it is okay, for showing you demo it is okay, but in real time for you, you need to create a persistent volume, because at least this data should be available for 1 week. If I delete the pod now, then data will also will be erased. Then how can you get yesterday's data? Logs are important. So if logs has been erased, then it will be a problem. So that's why make sure that you can use persistent volume. Okay, so this is Elasticsearch. And Elasticsearch I have given actually two uh, replicas, but actually we need to provide three, because it expects some resources. So that's why I deleted from 3 to 2. If you have enough resources, better to give 3 replicas for Elasticsearch in real time. And Fluentd, and for Fluentd there is a config map. So why config map for Fluentd? Because when you are opening in the dashboard, how you want to view the logs, okay, that will be defined inside the Fluentd config map. So here if you see pattern, like how it should be captured, what it should be captured, how we can see, these are all the patterns. So this will be defined inside the Fluentd config map file. So based upon this, the format, the log file format will be displayed on the Kibana dashboard. If you want to do any modifications, you should do modification inside the config map file, so that the output will be in that way. Okay, so how it should be. And this is a Fluentd deployment. And if you see here, here also same, for because it's going into the worker node and it is taking the information, right? So it should have permission. So that's why this roles and service account is getting created, and this is a deployment of application. And kind, if you see daemon set, and you don't see any replicas over here, because for daemon set we don't give replicas, it will not work. Automatically it's responsibility to go and deploy. Okay, and this one Kibana deployment. So this is kind is deployment. This is our deployment type. Okay, and replicas one. If you want, you can give two, but we can have one. In production, we can use 2 or 3. Okay, so here this name, how it is, this is the name of the Elasticsearch hyphen logging value. Always remember, whatever the, this is a Elasticsearch service, right? What is the name of this service? Elasticsearch hyphen logging. So this name and the port number is for Elasticsearch 9200. So Kibana, from where it should get the logs, means the data from Elasticsearch. So how Elasticsearch it is communicating? So whatever the name is there, that with that name, the cluster IP is getting created, the cluster service. So if you see in the Kibana, sorry, in the deployment, you see this is the service name, Elasticsearch-logging. When I deploy, I will show you, it will deploy with this name. So it will connect to the Elasticsearch. So here you need to give the value. In case if you are changing the name of the service for Elasticsearch, then make sure that change should be also available here also. Okay, and also in the config maps of Fluentd, because Fluentd is sending the logs information to Elasticsearch by using the service name. But if you are changing the service name, then it cannot communicate. Somewhere it will be available. Let me filter it. See here. Elasticsearch. Elasticsearch. If you see here, host Elasticsearch-logging and port 9200. Host means what? When you deploy Elasticsearch, the service also gets created and service name will be Elasticsearch-logging. So Fluentd also connecting to this and sending the logs to this port. Okay. So if you are changing the name of this Elasticsearch, then make sure that change in these two locations, or otherwise your Fluentd and Kibana will not communicate. And this is the Kibana service YAML file. Okay. So I'll deploy tomorrow and I'll show you how to deploy and how to check the logs. Any doubts? Okay, then we'll meet tomorrow. Thank you guys. Thanks everyone.
Praveen,
Yep.
um, Praveen, I have a doubt. It's not related to this one. It's related to a Jenkins. Okay, a general doubt.
Mm.
Can I ask that?
Yeah, tell me. If I know, I will tell
Yeah,
you.
yeah. Okay, okay. So what I'm doing is actually, in our like office work, so we are like automating something. Okay, so related to a user access and all. So there is a Git repository. Okay, we are
Mm.
using Jenkins. Okay, so as a service, we are using that Jenkins, and like we are pulling that Git repo. Okay, so for that, like
Mm.
I have created a credentials and using GitHub Access Token. Okay, so the repository it is cloning. Okay, and in that particular repository, there is a file. Okay, which is go.mod. It's a Go file. So that Go file, what it is
Okay.
doing is it is pulling. Okay, it is referencing to some other repository. Okay, so
Okay.
when I like pull that complete thing. Okay, what it is telling us, so the second repository which that Go file is referencing, so it is not able to pull that. It is saying credentials are you don't have authentication for that particular repository.
Mm-hmm.
You understood, right?
So
The
is it
main
public
repository is,
repo?
yeah,
The
yeah, yeah.
second repo which is trying to connect, is it public repo or
Yes,
private repo?
public. We tried in local, it worked clearly, completely. But when we are doing with
Hmm.
automating this using Jenkins, so it is not working. From past 3 4 days, I'm trying, not
So
able
it's
to
not
understand.
problem with Jenkins, I think so. The file
Okay.
which you are telling inside that, if you mention the repos, okay,
Uh,
so that file problem might be. It's
but it
not problem
worked
with
in
the
our
Jenkins,
local
right?
machine,
Jenkins is
Praveen.
triggering local machine. How installing Jenkins in local machine? Or see, when you
Normally, I mean,
execute that file,
hmm.
yeah.
No, what I did
So
in
when you
local
are executing
machine,
that file, hmm,
I cloned that
tell me.
repository. Okay, so when I clone that repository, so it is pulling everything and it is
Hmm.
running. So I'm able to run successfully. But in Jenkins, when we
Okay.
do that, okay. So it is
How
not
you
able
are
to fetch that.
executing that file?
It's a Go file. Okay, so basically, like we have set a Go path. Okay, and in that
Hmm.
particular Go path, we are cloning this repo. Okay, and after cloning that
Okay.
repository, there is a command. Okay, which is called as make deps. Okay, it's a
Okay.
dependency make deps. It is in make file. Okay, so there is a make file, and when we do make deps
Hmm.
in make file, there is a dep section. So that dep section
Okay.
has repositories. Okay, that dep section
Okay.
has other repositories. So there, we are getting error in that particular step, but in local it worked easily when it was successful.
Okay. We need to check that. If you send the screenshots of the Jenkins, how it is configured, then I can get
Okay,
some idea, okay, how we can configure. Because until unless we log into that, we can see, we don't know
okay,
how exactly. If I configure the same thing, then I can get immediately idea, okay, this is how we need to do that. Apart from that, if we want to troubleshoot, we need to see how it is configured. So if possible, just share the
okay,
screenshot so that I can have a look, okay, if anything we need to correct it.
okay. So can I share in WhatsApp for you? Is that fine?
Yeah, you can share.
Okay, Praveen. Okay, okay.
Okay. Okay.
Yep. Thank you, Praveen.
Okay, guys. Thank you. Thanks, everyone.